Hello Internet, Parag Dhawan here. We are on day 7 of Kaggl's 30-day machine learning challenge, and today we will see how to work with external library. First, import statements. Let's understand this by example. If you want to import any external module or library, you write import and library or module name. In this case, we are importing math module, and then in the next statement we are printing it's math. It has a type. Dot format. Type of math. It will be object of module. Click on the cell and run the cell. When you execute the cell, you can see the output. It's math. It has type class module. If you want to see the attributes and methods present inside math module, you will run the statement print dir math. So dir function shows all the attributes and methods present inside a module. Click on the cell and run the cell. You can see all the attributes and methods present inside math module. In the next cell, we are printing the value of math. We are using dot format to print the value of pi up till 4 decimal point. So inside the placeholder, we have used :.4. This will take the value of pi and print it for 4 decimal points. Rest of the statement will be printed as it is on the user screen. Click on the cell and run the cell. You can see pi to 4 significant digit and output 3.142. Math module also has a log function. We are calculating log to the base 2 of number 32. So using math module, therefore math dot to access the method log, and we are passing parameters. First is 32 and log to the base 2 is to be calculated. Click on the cell and run the cell. You can see log to the base 2 of 32 is 5. You can see information regarding log function of the math module using help. So you will write help in opening and closing parenthesis math dot log. Here you will not call the function, just give the name of the function to get the information. Click on the cell and run the cell. Help on built-in function log in module math. Signature of the function log. First parameter x, second parameter base. Returns the logarithm of x to the given base. You can see all the information regarding help module using math module using help function. Click on the cell and run the cell. Help on module math. It will give you all the information of the functions available along with their signature and docstring. Going to the next part. When you are importing any library, you can give it a alias. For example, in this case, we are importing math library and giving it a alias empty. So instead of using math.py, now you can use empty.py. So to call any function or attribute of the math library, instead of using directly math, now we will use empty. Click on the cell and run the cell. Empty.py will print the pi value. Next, another syntax for giving a alias: import math, empty is equal to math, and now using empty you can call any attribute or function of the math module. So empty dot pi will print the value of pi directly on the user screen. So you can use import math as empty or import math and give it a alias empty. Both are same. Another syntax for importing any external library or module: for math, import star. What star will do, it will import all the library functions and attributes. They can be used directly in your program. So when you use from math import star, all the functions are available. So directly we are printing the value of pi and calling the log function for 32 to the base 2. Click on the cell and run the cell. Now in this case, we don't need to use math.py or empty.py. Why? Because all the functions were directly available. One problem in doing this is if you have two libraries having same function name, then that will throw an error. For example, from math module we have imported all the functions and attributes. From NumPy module we have imported all the functions and attributes, and then if we are running print pi and log32 statement, this will report an error. Why this is so? You have a function which is colliding with math as well as NumPy. Therefore, it throws an error. So in that case, what you can do? From math, you can import all the functions or constants which are required. So in the first statement, we are importing log and pi. And from the second statement, we are importing as array. As required, you can import the constants or function and then you can use them in your program. So it will not throw any error. If you run the cell now, it will run successfully. Submodules. So inside the main module, you have submodules, and for those submodules, you can run the function. So in the example, we are importing NumPy, and for the NumPy module, we are using a random module to generate random numbers. Import NumPy library will be imported. We will print numpy.random. So it will display that it is a submodule available inside number NumPy. In the next statement, we are printing it contains names such as dir numpy.random, and it will we will print last 15 attributes or functions of numpy.random submodule. Click on the cell and run the cell. You can see it contains triangular, test, standard, dart, normal, attributes and operation inside NumPy module, random submodule. So if we import NumPy as above, then call the function random submodule will require two dots. Understanding this by example, from the NumPy module, we have imported random submodule. From the random submodule, we are running randint function. We want to generate random integer. So we have to provide keyword argument low is equal to 1, high is equal to 6, and how many times they are to be generated. So size is 10. So it will generate 10 random numbers between 1 to 6 and store it in roles variable. If you print the role variable, it will be an array containing random numbers between 1 to 10. Moving to the next part, if you want to understand a totally new library, then these functions will help you to understand the library. For example, type function. Type function will show you what the type of object is. If you have type roles, you can see it is a NumPy object and dimensional array. If you want to check what are the functions are available inside the roles object, you can use dir function. It will tell you what you can do with it. Click on the cell and run the cell. You can see all the attributes and methods available inside the role object, which is a NumPy and dimensional array. Inside it, we are running main function. Roles object, when you call main, it can compute the mail and display it on the user screen. If you want to convert a NumPy array to a list, then rows to list function will convert the array to a list and print it on the user screen. If you want to get help regarding any function of the object, then give the name of the object dot the attribute or function for which information is required. So in this case, we are running help function on role object travel. We are not calling the function, we are just giving the name of the function to get the information. Click on the cell and run the cell. Help on built-in function Ravel. Ravel method of NumPy ND array instance. What does it do? It returns a flattened array. So n-dimensional array is converted into a one-dimensional array, and it will return to the user on the user screen. You can see help above regarding roles, which will tell you the information about role object. It is a ND array object. Then it will show all the attributes and operations which are available inside the roles object. Operator overloading. Let's understand this example. You are passing a list and you are adding 10 to it. This is a vector operation which is not supported by list. Means you want to add each element of the list with 10. So this is not supported by list. When you click on the cell and run the cell, this will throw an error. But it is supported by NumPy array. Means all the elements of NumPy array will be added to a value 10 via broadcasting. Click on the cell and run the cell. So addition operation, instead of performing integer addition, if it is supplied to an array, it will add the scalar to each element of the array and print the new array on the user screen. You can store it in a variable and then you can use it later. Next example, we are checking whether every element of the NumPy array is less than equal to 3 or not. It will return a value true or false depending on the condition if it is satisfied. Click on the cell and run the cell. For first element it is false, for the next element it is true, for the next three elements it is false, second last two elements are true and last element is false. You have a list and dimensional list. Here you have two-dimensional list. This list contains two sublists 1, 2, 3 and 2, 3, 4. We are converting this into a NumPy array using asArray function. X is equal to NumPy library asArray function, and we are passing XList. So we are printing X and XList. So you can see the difference between two-dimensional list and two-dimensional NumPy array. Here you can see XList is a two-dimensional list and X is a two-dimensional NumPy array. To get the last element of the second row of NumPy array, you can use name of the NumPy array. We want to access the second row. So second row is first row is indexed by 0, second row is indexed by 1. So second row is accessed, which is 246. Then we want the last element, therefore we are writing an index -1. Click on the cell and run the cell. You can see 6 was given output on the user screen. The same operation if you do it on a list, then it will throw an error. List indices must be integer or slices. It should not be tuple. So you have to use slicing. When you convert this in such operation where you are from the XList, you are accessing the first row, and from this result which is on the user screen, just selecting the last element, it will display 6. Moving to the next example, here we will see operator overloading on plus operator when you use TensorFlow object. So when you are using TensorFlow library, everything is a tensor, either one-dimensional tensor, two-dimensional tensor, three-dimensional tensor, so on. So that vector operation can be done on it. So in the next example, we are importing TensorFlow library, giving it an alias tf. We are creating a constant tf.constant1 and storing it in a, tf.constant1 and storing it in b. So you have created two tensors a and b. When you are adding tensor a and b, it will create a new tensor with the value 2. So click on the cell and run the cell. You can see it will take some time for execution, and then it will show the correct output. You can see the newly generated output is a tensor. It is of data type int32 and it is a NumPy array containing an element 2. Moving to the next part, we have understood how operators work when they are applied to int, string and list, but the same operation if they are applied to tensors, NumPy arrays and data frame, they will work differently, means the operators are overloaded. Same operators give different output when they are applied to different data objects. So here is some example wherein we are applying operators on a data frame. We are selecting a population column of data frame and checking whether it is greater than 10 to the power 6. It is a expression combining two conditions, so we are assessing continent column of the data frame and checking whether it is South Africa or not. If these two conditions are satisfied, then that value of the data frame will be printed, that row of the data frame directly printed on the user screen. Moving to the next part, if you have an object from unknown library and you want to understand what is there inside that library, you can directly go for help@dir function. Now your library has some double underscore attributes. So here list, if you run a dir function on a list, it has double underscore attribute add class. So when Python programmer want to define how operator behave or their type, they do some implementation method with special names beginning with ending two underscores, such as underscore underscore lt underscore 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 set attribute underscore underscore or underscore underscore contains underscore underscore. For example, if in operator is applied to a list, it will show that whether the element x is present inside the list or not. It's actually calling the dunder method contain, and the actual representation is on the list. You are calling the contain method and you are passing the argument x. This contain method contains implementation wherein which shows result of x in 1 to 3. That's it for today's video. Thank you. Thanks for watching. Do hit that subscribe button for more such technical content. See you in the next video.